Hi there, my name's Dave. I don't usually make YouTube videos, I usually make video games, but I wanted to show you some cool stuff in my favorite engine, Pico-8. Now this is video number 2, so we got some things out of the way you should review if you're a total beginner, but we're here at pico-8-edu.com. We can start it up. There we go, we're in our command line, escape, got our code. Now, we want our 3 main functions, which you might not remember, but it's important to try and remember. You might try to learn programming by watching somebody like me and copying what they do, and then later you can't get it out of your head. It's just the knowledge is like, where is it? And you have to actually practice recalling that knowledge. So I want you, even if you have no clue, try and write the 3 functions, and there's no judgment, little test. So pause the video, do that, and I'm just gonna do it now. So you should be able to do this as your goal, right? Is to just yeah, I know the 3 main functions of any program, and you might, if you totally wiped out there and had no memory, this is a good opportunity. You've got it here, you can sort of focus on it, try to store it in your brain, and then just go like this and be like, what was it again? What was it? Was it like fun time emit? No, because it's not lighting up. What was it? And you can go back and be like, right, function in it. Okay, I got it. So it was function. Yeah, it lit up, and it, and get it into your brain, get it into your bones, so you're not even thinking about it. And a lot of stuff in programming will be like that. Just try and quiz yourself. Don't look at it. Remember, oh yeah, and type it over and over and over. And that's part of why I threw away everything we did last time, because I think especially at the beginning it's important to do this over and over and get the muscle memory, right? And that way you'll be set up for success when you've got that toolbox in your mind. All right. So last time we had a little guy running around, and I showed you some stuff. I showed you variables, right? We were x equals 64, y equals 64, right? I want to show you a different kind of variable, a different way to store data. Because in programming, the way you store your data so that it's easy for you to use is a big part of it. So this is a variable that just stores a number. Now, what if you could package up all these numbers? Because, all right, look, I'll show you. Here's our goal. We want to make a star field. So just a lot of little points that sort of move across the screen in a cool way. And that knowledge will help you with anytime you need more than one of something moving around on the screen. So we could be star 1 x equals 64, star 1 y equals 64, star 2, right? And have just a trillion of these. And that would be a mess and really hard to deal with. So wouldn't it be cool if we could package all the data about a star into something? And what you can do is use something called a table. And the way you initialize a table, on your keyboard, there's the little square brackets. You want to shift and get those curly brackets. Slightly different, but the difference is important. And then you can put stuff into these brackets. So you could be x equals 64, comma, y equals 64, comma, and we'll do speed equals 2. And you can, it's a good idea in these things because the last one doesn't really need a comma. It's a list of things that are inside this table. But if you wind up rearranging things, or you go back, like if this one didn't have a comma and you're like, I'll just add one more. This one then needs a comma and it'll break. You could just put a comma after all of them. That's generally a good idea. Yeah, and we'll do like C for color, and we'll just make the color 7. Okay. So that like packages all that up. And then the way you can access this table in our draw function. And let's see, what do we want? We just want to draw a pixel. And the way you do that is using pset. You can do help pset. Right? Get or set the value of a pixel on the screen at x and y. So for pset, it's x, y, and the value, which is the color. Cool. So what we want to do is pset, and our x will be star dot x, star dot y for the y, star dot c for the color. So what this is doing is, it's saying, hey, remember that table that we made star? I want you to access the x value that's inside that table, which is 64. And the same for the y and the same for the color. And you can run that, and let's do our CLS. And hey, we made a little dot in the middle of the screen. That's great. Now, you might be asking, like, what am I going to do, like, star 2 equals, and like do this table? How is this saving us any space? All right, let's back up. Let's back up and get rid of this. So what we really want, we want a little factory for stars, okay? Just to keep things organized. Up here, you see this little like tab thing that says 0? There's actually a way to sort of organize your code, and you can click this plus, and it gives us a new tab. And we can leave a little comment for ourselves at the top here, and we can say this is our tab about stars. And when we mouse over, right, we can be in tab 0 and we can mouse over, right, this is where we're keeping our stars stuff. All right, let's make a little stars factory. Okay, so we want to write our own function, and we'll call it make star. All right. And we'll say local. This is a new one. Hang with me for just a sec. Local, and we'll just keep it short. S equals. And then we'll do like, we'll just do standard, because I don't want to go too fast here. What else? Speed equals 2. Okay, this is like the same code, right? And then we're going to say the factory is going to do this inside itself, and then it's going to hand it back. And we're going to return S. Okay? Now, we kind of have to talk about something called scope. All the variables we were doing before, where we were just like x equals 10, since there's no keyword local before this, it's a global variable, which means you can access it anywhere. Super convenient, right? Like you could access it in the update, in the draw, anywhere you wanted, and change it anywhere. But that means that there's like all these sort of conflicts. Once you have a global X variable, you can't have another one. If you try and do it again, it'll just overwrite. So this one is local. We're saying we only need this variable inside this block. Remember, we're like, we've got this end, we've got this function, and then we indent inside this block of code. This local says this variable is only useful inside this block. Afterwards, don't worry about it. All right? So what we're doing is we're making this local variable s. We're making a table. We're putting some values in the table, and then we're handing it back to whoever called this function. So we can say my star equals make star with the parentheses. All right? So just like these are functions that we're calling, little machines, little factories that do things, we made our own. So what this is doing is we're calling this function that we made. It's going to jump over here and do this, and then it's going to return a value. It's going to send it back and set it to this variable. All right, this is getting a little long. We can format this in a kind of nice way. I like to do it like this. And that way you can sort of see like these are the things that we're passing into this function. It keeps it nice and organized on the screen. What did we do? Aha, underscore. There you go. All right, same exact thing. Now, what if every time we made a star, the position was a random spot? All right, so we can use a handy function called RND. Let's do help RND. So RND, you can pass in an optional value or an optional table. We'll kind of get to that. Returns a pseudo-random number from 0 up to but not including x, which defaults to 1. So if you don't pass in anything, it's 1. When a table is given, a random item from the table is returned. We won't worry about that right now. So like we can test drive this. We can do question mark, which will print the return value to the screen, RND, and okay, 0.6608, 0.8149, 0.9941. So it like almost gets to 1, right? But as many times as we do this, it'll never actually be 1. But it'll always be a value in between 0 and 1. And what if we pass like 5 into this? Then we get like 3.35 whatever, right? And it'll never be 5, I don't believe. Let's do the help again. Up to but not including x, right? It'll never hit 5. It might be 0. But yeah, it's a random number. And it says pseudo-random because like the way computers work, being actually random is kind of hard. Anyway, so we can do random 128. That's the width of the screen. 128 for the height of the screen. And let's just see what happens, right? So every time we hit Control R, now we've got a star. Our star is in a different place. So that's kind of interesting, right? One star isn't that impressive. You know what's impressive? A billion stars. We're not going to do a billion because that would break our computer. But let's make a table of tables. So every star is its own table, but we can organize a bunch of stars into a table. So we'll do stars equals, and we'll just make an empty table. And we can do add. Let's ask Pico-8 about add. Add value val to end of table TBL. All right, what does that mean? We give it our stars table. And then we can use our function to make a new star. So what this is doing is it's making a new star with this data. It's returning it here. And it's using this function add to add our star table to our stars table. All right? And we can do this. Copy this. We'll make like 5 stars, all right? Every time this is doing this, it's making a new star for us from our factory and adding it to our table of stars. Now, the way we access this is a little different. It's gonna be a pain if we have to like write this out like this, right? Because then we're gonna have to be like, stars and then 1, right? That's how you access when things are like in order, the way we're doing here. We don't want to do this like 100 times. This is ridiculous. So I'm going to teach you something else. A lot of what you do in programming is writing a loop to tell the computer to do something over and over and over that I don't want to do myself. It's very good at doing the same thing over and over and over with like little changes in instructions. And like this sort of functions, this is secretly in a loop that the computer, that the Pico-8 runs for us, but we can make our own loops. The for loop is a really basic loop. And just follow along with me here for a second. I equals 1, comma, 100, do, end. Let's just do print I. We'll get rid of this. We're just going to run a little experiment here. And then I'll explain what's going on. Look at that. All right. So what did that do? What happens if we do for I equals 1, comma 10? Run that. We got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that what happened up here was it did the same thing, but up to 100. You could do like 1,000, right? Super impressive, I know. What's the point of this? What's happening is we're saying, give me a local variable. We don't have to write local. It's just sort of part of the for loop. We're going to call it I. You can call it anything. The standard usually when you're writing one of these is I. You'll see that a lot. Say set I to 1. And you're going to stop when I is equal to 1,000. And then you're going to run this block of code. And every time you go through, you're going to add 1 to I. So you can see it doing that. It's just looping. It's adding 1 to I. It's printing I. It's looping. It's adding 1 to I. It's printing I. We're getting up. And then when it hits that limit, stops. So instead of doing something useless like that, we can do add stars make star. All right? And we won't see anything there. But what's happening is it's adding 1,000 stars to stars. Well, we'll make it 100. Let's not get too wacky. Now, what can we do? How can we see those stars? We can do another kind of for loop. We'll say for s. But this time, instead of like s equals 1, you could do that, but we'll do s in all stars do. Now what this is doing, we're saying give me a local variable called s, but instead of just like giving it a number, we're going to say, we're going to have this all function that loops through our table of stars and takes out each star individually and says, we're going to call this s for just a minute so we can access it. And we can do pset s.x s.y, s.c, right? So we're getting the values inside that star table that's in the table of stars that we made using our star factory. Let's get our CLS in there. All right. Now we can see our random stars. And it's different every time. 100 stars. You could make 1,000, and it would be a little A little much. This is a good number of stars, right? And you can change your star factory. You could make it only on half the screen, right? You could do all sorts of stuff. You could change their color, right? And let's see what. One of the things that is the help set about R&D is you could pass a table into it. When a table is given, a random item from table is returned. So we could just put a table in here. And, you know, 7's a good color for stars, but like some stars could be a little like grayish, right? Some stars could be like kind of dark, right? So what if we just wanted to grab colors 7, 6, and 1? We could just write a little table right here, and it'll randomly pick one of these values out of this table and make that the color. So yeah, we've got some different colored stars here. We could get color 13 in there. Ooh. Suddenly our star field it's got some variety to it. Let's see. What are we going to do with this speed? Well, here's what we can do. In our update, which is where we put our logic, right? So we put all our drawing here. We put all our logic here. We could do for S in all stars, right? We're just looping through all our stars again. We could do S dot Y equals S dot Y plus S dot speed. Oh. What if we wanted to give them all different speeds? We could do R&D 2. Oh. Kind of cool. But then they don't, they just kind of fall. Not great. So we want them to loop around the screen. Now we could do if S dot Y is greater than 128, then S dot Y minus equals 128. That works. That's kind of a, I don't know. It's not my favorite. You know, that's not bad. I could show you two things. Because like you start to sort of see the patterns if when a star goes to the bottom, it's in the same X position when it comes back out at the top. You could do at that point S dot X equals R&D 128 and like randomize it again. That's kind of cool. And you might want like a minimum speed. So you could do like R&D 1 plus 1, right? So it's like guaranteed. If R&D gives you 0, it's going to be like a minimum of 1, right? So yeah, we've got a nice kind of randomized star field here. Let me show you a little math thing. Question mark will print a number to the screen, right? We can do like 5. And it'll print 5. If you do like 5 divided by 3, 3 goes into 5 1.666 repeating times. If you do like 6 over 3, it's an even 2, right? You have 3 goes into 6 an even number of times. Sometimes you want that remainder. 5 over 3 goes into it 1 time, so like what's left over is 2. A way you can get that is called the modulo. 5% sign 3. That'll give me 2. It's what's left over after the division. So if I do 3 modulo 3, it's 0. Because 3 goes into 3 evenly. There's nothing left over. If I do 2 modulo 3, it's 2, right? Because we haven't got enough to reach 3, so there's a remainder. If I do 6 modulo 3, make sure we have our question mark, it's 0. 3 goes into 6 an even number of times. Now, why is this useful? Well, you can kind of make like a loop. So I can do s.y equals s.y modulo 128. What this does is it does this division of our y position divided by 128, throws away like however many times it goes into it, and just gives us back that remainder. And effectively, when it is equal to or greater than 128, it loops it back to 0, which is what we want. And this works in reverse too, weirdly. When s.y is negative, it'll loop back and like start out at 128. So we can do it in reverse as well. Real handy. Modulo is like a weird math thing that I had never heard about until I started programming, and you use it all the time. So it's good to sort of play with this, get used to it, understand it a bit, and you'll sometimes think like, wow, I just need this number to loop. Oh, modulo, that might be helpful. And you start to get a feel for it. So all right, there's our star field. All right, just to review what's happening, we make an empty table. We use our for loop. Our local variable I starts at 1, counts up to 100 every single time it loops. We do add to our stars table, call our function make star. Over here, we made our function make star. It makes a local variable s, makes a new table, makes a random x, random y, random color, random speed, and then hands it back. So we get handed back that table. It gets added to our stars table, our table of tables. Every frame for s in all stars, we loop through every star in our table. We call it s temporarily. We access the variables inside that table. s.y, add its own speed, loop it, clear the screen in our draw, get every star, and then just draw it to the screen. It's S, it's Y, and it's C. Great. And we could have some fun with this. We were playing in the editor here. We can draw ourselves a little spaceship. Let's make it red. Make it red and white. Pretty cool. Racing stripes. Cool. We've got ourselves a little spaceship that's in sprite 1. We can make little comments to ourselves. We can say set up stars, and we can say set up spaceship. All right, ship equals. We'll make ourselves a table. We don't have to be too fancy here. We can say x equals 64, y equals, we'll put it down towards the bottom of the screen, but not too far. I don't know, 110. We'll do, you know what, that's fine. We will say this is where we draw stars. And then in order, we want to draw the ship above that. And sprite 1, ship.x, ship.y. That should draw ourselves a ship. You know what? I kind of want the x and y position of the ship to be like the middle. Usually when you draw a sprite, you draw it from the upper left-hand corner. But I kind of want it to be like the middle here. So like sprites are 8 by 8. We'll do ship x -4. -4. I think that makes sense. So that's like in the middle there. We're just offsetting the drawing. This is our update stars. And then we want to update ship. Now, let me show you something. We took player input before, and we wrote like if button, and we looked up our button codes here. And we did these numbers, and I never remember the numbers. Now, you might have noticed, if you tried to type something with capital letters, you got like a bunch of crazy symbols. And you're like, what's the deal with that? All the code in Pico-8 is written in lowercase, which sidesteps a ton of issues. And like other programming languages, it really depends if something is uppercase or lowercase. And some of them like assign meaning to that. It gets real weird. It's kind of a gift that Pico-8 is like, let's do all lowercase. But there's cool stuff you can do with these symbols. And a shortcut for these buttons, you can just do the symbols for the buttons. And you can do Shift U, and that's the up symbol. So there's U for up, D for down, L for left, and R for right. You can also do, because there's these two buttons, O and X, right? Shift X is the X button. Shift O is the O button. And like, Pico-8 is trying to be like a console, like the Game Boy, where there's two buttons. The X and O buttons, they map to like several different buttons on the keyboard that are convenient. But we're sort of pretending like it's a console that has two buttons like a Game Boy. So it's not really, you're not like pressing O on your keyboard. Although X is really X. Anyway, let's do a little trick. Because we can do button Shift L for that left, then, and then we gotta have this block of code, ship dot X equals ship.x -1. That's kind of a lot to write. We can shorten this, and I'll show you a couple tricks. If parentheses button parentheses L, this is a short version of an if statement that just fits on one line, and you don't write an end. You write it on one line. So if button left ship.x equals ship.x -1. If button right ship.x equals ship.x +1. All right, we got our left and right here. It could be a little faster. We could give the ship a speed. Now this is starting to get a little long. ship.speed, ship.speed. We're getting real over here. Let me show you a trick. I'll write it on the next line. You're used to writing like x equals x plus 1. We're saying, you remember x? I want you to set it to whatever x is plus 1. There's a short way to write exactly the same thing. X plus equals 1. Now, that's not that much shorter looking when our variable's short, right? But if it's ship.x equals ship.x plus ship.speed, that's pretty long. But if we can just write ship.x plus equals ship.speed, we saved ourselves a decent amount. And you can do minus equals. You can do times equals. This is a nice feature of Pico-8. This is not vanilla Lua. Lua doesn't let you do this, but Pico-8 lets you do this. Just like doing this one line if, vanilla Lua doesn't let you do that. This is a nice thing in Pico-8. So we can do plus equals and minus equals here. And look, that fits on our screen now. That's nice. And so, hey, look at us. Let's upgrade our update to update 60. Smooth, fast. And you can do if button up ship.y minus equals ship.speed, if button down ship.y plus equals ship.speed. All right, and now we can move all over. What if we wanted lasers? What if we wanted to shoot? Because what's a video game without shooting? What we can do is make a circle, fill it in. We can give it a little dimensionality here. You don't have to be a great artist to work in pixel art, but you know, doesn't hurt. Maybe make it look like it's kind of glowy. It's not bad. What's the secret to making a good bullet? Well, maybe we'll make it kind of long. All right. Let's see it. Let's see how this looks. You know, maybe we can like taper it a little. That's kind of interesting. All right, let's give it a shot. So that's sprite 2. Let's Oop, I got my caps lock on. Let's set up bullets. We'll do bullets equals blank. Let's make a new tab for bullets. We'll do function make bullet. Local b equals return b. Now, just like our other things, our bullet is going to need an X, a Y, a speed. Let's give it a life. Let's give it a life of 10. Now, when we fire a bullet, we're going to want it to appear in a certain place. Like when we made our stars, we got to be just like random with it, right? And when we made our ship starts in a specific spot. But our bullet, we kind of want to be able to start it anywhere. Because it wants to be fired from the ship. And we could just say, like, where's the ship now? But I want to show you something. We can define arguments here. Now, let me just show you, like, I've got some of these system functions that take in arguments, right? And we've been using them. We give this little function an input, and it gives us something back. It returns something, like a true or false, which is like how this is all working. In the functions we've written, like make star, you don't give it anything, because it just does one thing. It doesn't care. It doesn't have any input. But we can make functions that take input. So let's say our make bullet function expects an X and a Y input. And we can say in our local variable X equals X, Y equals Y. So what this is saying is, this first one is the X that's inside our bullet table. And it's smart enough to know, I want to make a new variable inside like that b.x. And I'm going to set it to whatever was passed in. So this is sort of making local variables in here, but whoever called this function is passing in the numbers that are going to be assigned to these. So we have to write a function like we don't know what this is going to be, but we're going to use it. So we're making a temporary bullet. We're setting its X and Y to this X and Y. We're giving it a life, and we're returning this table that we made. So we don't, with the stars, we just made a bunch at the beginning, loaded them up. With bullets, we want if button X, then, actually we want to use if button P, which is slightly different. It's the moment the button is pressed and not every single frame it's down. So if button P, X, when the X button is pressed, we want to shoot a bullet, which is like we want to spawn a new bullet at the, like around the X and Y position of the ship. So we'll do add bullets, because remember we made a bullets table. We want to add to that table make bullet. But we need to pass in an X and Y. And I'm going to format this a little nicer. Make bullet, and we're going to do it at ship.x, ship.y. And maybe like a little bit above. So we'll do ship.y -4. Okay. And then we'll need to like draw our bullets. For B in all bullets, do. All right, it's just like drawing the stars, but we're going to do sprite 2. That's our bullet sprite. B.x -4 B dot Y minus 4. We do like the same offset, so it's in the middle of that sprite. Yeah, so they don't go anywhere, but we're drawing them wherever we want. And they're appearing at the ship when I press the X key. Right? And they don't disappear. We're getting there, though. So we want to update bullets. We'll update them here. For B in all bullets, do B dot Y minus equals B dot speed. Right? I think we gave the bullets a speed. Yeah. Oh, look at that. Speed can probably be faster. Don't want to make it too fast. But I think that looks pretty cool. Now, those bullets are going off the screen, but they still exist. Trust me. And if I kept doing this forever, we would fill up our computer's memory and it would crash with just bullets. And I think even before that, it would, because it's still like adding numbers together for all the bullets and looping through all of them. It would start to slow down. It would start to chug. Now there's a couple ways you could do this. Let's slow down the speed. We gave it a life, and I'll kind of show you what we can do with the life. We can do b.life minus equals 1. And the life is kind of like a countdown. And then we can do if b.life is less than or equal to 0, then now we need a function to do with tables. Here's our tables section. We've got this add, and then we also have del for delete. And we can do del bullets is the table, comma, b is itself. And this will say, pull me out of that bullets table. So we can see it's alive for like a second. We'll increase the speed. Will it still be on? Oh, yeah. And after, what is it? 10 frames, pull me out of the table. And we can make this like 60. Let's see how long that is. That's like off the screen. We'll say 30. All right. So you can have multiple bullets on screen, but then they get pulled out of that table and destroyed, forgotten about. So we don't have to worry about a memory leak. We don't have to worry about that table just growing and growing and growing and soaking up all our memory. I think that is good for today. We learned about making our own function that returns a table. We learned about tables. We learned about passing in variables, passing in values that we can use to make our standardized tables that we can then use later. We used for loops to go through tables of tables and use the values in the tables, access the variables we set in those tables. And you can start to see, like, what else could we use tables of tables for, right? Like, you could have all your enemies in a table, and it's looping through your enemies and having them do the logic of them chasing you or shooting at you or whatever. If you were making something like Tetris, all your blocks could be held in a table, and it's looping through this table to bring them down and figure out when to clear them and pull them out of the table. And, everything in a game is just sort of data, and you're organizing that data and running instructions on it and figuring out what to do with it. And that creates the illusion of things happening for the player. So thanks for joining me. I hope you learned something. I think what you should do now is delete everything and try and remember stuff, right? Remember to practice recall. Try writing for loops. Try writing it with numbers. Try iterating over tables. Try random numbers. Try pulling things from a table. Try playing with the modulo, that percent sign. You can do a lot of cool stuff. Have fun and pretend I have a cool catchphrase to say at the end of a video.